So this is a session about LTE, and I'm going to talk about NB-IoT, which is a version of the technology standard oriented towards low-speed devices, lots of them, massive amounts, and it comes out of the LTE standard, but it is in fact a 5G standard. Let's see if I can match this. So it's a little bit of getting ahead, and as we think about LTE, I really encourage all of the parties, particularly with regard to buying the spectrum, using the spectrum, however you obtain access to the spectrum, to think about not just 4G, but where are you going as the industry evolves, the overall industry, not just the utilities, but as the wireless broadband industry evolves towards 5G. So we'll talk in the beginning here about NB-IoT, what is it, why is it relevant to utilities. We'll talk briefly about how that fits into the, as most of you know, I'm representing Union Capital. A lot of you know Don Cluster, who represents Access Spectrum. So between us, we've sold about a third of the country, coverage of about a third of the country in the upper 700 megahertz A block to 20 different utilities. And of course, we hope to sell the other 2/3 to another 40 utilities or so. While NB-IoT is not the answer for every utility, we think that, by the way, existing use of this band is one utility is using NB-IoT and 19 are using other technologies from companies like 4RF and Max and GE. We still think it's relevant to look at this for really a different set of applications. Then I'll talk about 3GPP. I'll talk particularly about whether utilities should maybe get more involved than they have been in these standards because they have a lot to do with where you're going. And then I'll introduce a concept that we call DUET, that stands for Dual Unified Efficient Transmission. Made that up myself, by the way. That's not necessarily an industry term, but basically it involves using two bands, one for coverage and one for capacity. It's used by all the carriers, and it's relevant, I think, to utilities as we move towards 5G. So first of all, NB-IoT came out. It was originally LTE, NB-IoT. I think we released 13. We're now up to release 16. There are really three portions of the 5G standard. The one that everybody knows about is at the top of the scale here. It's multi-megabit, gigabit plus speeds to a mobile device. It's the exciting version of 5G that we hear. It's very relevant to the consumer space. It's also, I think, relevant if you want to do a drone with high definition video. Great application for broadband 5G or 4G. That's also possible within just the 4G standard. But there's also a version on the lower right that's called Mission Critical Communications. URLLC, ultra reliable, low latency communications. We're talking about latencies in the order of 1 millisecond. Potentially applicable in the utility space, but I think really intended overall for other types of applications. This is not yet really very well developed. But the third leg of the stool, and for my focus today, is on NB-IoT. It's intended for, and in general, machine-to-machine communications, intended for massive numbers of remote devices, low power, long range, and we think that fits many of the types of applications that are relevant to utilities. So I ask you to take a look at this and see if over time you agree. All right, so what is a low power wide area network? Because NB-IoT is an example of a low power wide area network. It's one of two types of standards that are appropriate within the 3GPP cellular type standards. Low power consumption, many of these devices can be battery powered. Doesn't necessarily make sense in all utility applications, electric utility in particular. Certainly can make sense in gas and water type applications, and in certain applications where the utilities, even Nightbud today was talking about, they're transmitting 450 kVA, whatever it is, these massive lines, but they don't necessarily have 110 or negative 48 volts at their particular location. So that can be helpful and important. It has to be secure, of course, high importance within the space. And what NB-IoT offers compared to other 3GPP standards, and really compared to the existing industrial radios, is the possibility of very low unit rate cost. These are relatively simple devices. The modules can be in the range of $50 or less. And so it opens up a wide range of capabilities. Particularly relevant if you have an unchatty device. This is not good for broadband. If you need high speed all the time, this is the wrong answer. But many of your applications, I think, do not require high speed all the time. So you'll see as we go through this, some of these slides are really pulled from industry sources. So that's good in that it saves me time in putting together slides. By the way, I didn't do all of this. We now have an engineer who's working with us. Unfortunately, couldn't make this trip, but I want to introduce anyone who has more technical questions to Mustafa Rashidi. But he put together the presentation in part on his own, in part based on common sources. So very low power, optimized power consumption, very long range, 20 dB better range at the same frequency than broadband LTE. So that'll give you up to 25 miles of range is what we've tested, or down into the basements. That has great capability. The goal, and we certainly haven't seen anything like this in the utility space so far, up to 10,000 endpoints per cell site. So potentially massive deployments if you're doing line sensor, pole-top sensor, anything to do with meters or individual customer sites. Talked about the cost advantages. It's slow, right? Less than 200 kilobits is something to take a look at. See, and that is, the system capacity for an individual channel, supporting a sector or a cell. So you can't have lots of devices out there that are talking. It is two-way. It has all of the encryption and security built in that is designed for the consumer space. So that is advantageous, and then of course part of the 3GPP standards. There we go. So use cases, utilities listed on the left there. Again, this is an industry slide. Agriculture, smart city, smart home. You're going to see a variety of different types of industries adopting this standard. What does that mean? That means unit quantities for the chips and modules in the billions over time. This is already a huge service in the public network, particularly in China. But you don't have to buy your equipment from China, right? You can get it from a variety of sources. Qualcomm supporting this. Sequans is a French company that's supporting this as well. So a whole range of applications and the opportunity to sort of leverage the volume that you see in these other industries. All right, so what is it? Of course, I'm taking a spectrum perspective on what it is first and foremost. 3 different options, right? So it only takes 200 kilohertz. It can operate either in band. So if you do have, a broadband carrier, 5 megahertz or more, or even a 3 megahertz carrier, you can slot this in band within that existing carrier. Now, it's not free. You lose some of the capacity of the broadband carrier. You lose some of the range of the NB-IoT carrier. But that's an option, and you don't have to buy separate spectrum for that. Essentially, the same thing goes with the guard band. You can use it adjacent to an existing carrier if you have a guard band. Most LTE carriers don't have a guard band that's big enough to accommodate 200 kilohertz, which is the size of an NB-IoT carrier, but it's theoretically possible, and certainly in the standards. And then the version that we're really talking about is standalone. So it means it's your own spectrum. You're operating NB-IoT in that capacity. Potentially, you could operate something else. If you have a megahertz and you're only operating a single 200 kilohertz carrier, then there's another 800 kilohertz that are available potentially for use. But standalone could be a single carrier, or we think up to 4, for example, in a 1x1. There's room for 100 kilohertz of guard band on either side. So this is the version, and we'll come back to a little bit about this. What are the neighbors here later in the presentation. So, in fact, not very much later, right now, in fact. So the neighbors are band 13, band 14, that's Verizon in band 13, AT&T, FirstNet in if you're looking at 700 megahertz. Again, NB-IoT can be done in multiple bands, but just for information's sake, it's already supported in these neighboring bands. And these are, this is considered to be, again, a 5G standard. 4G has evolved in the NB-IoT space already into 5G. So in terms of advertisement, this is spectrum that's available. It's available in almost all of the eastern portion of the country, in regions 1 and 2. First Energy is a holder of these licenses in a wide area. National Grid has them on Nantucket Island. But in general, the spectrum is available. Verizon is immediately below with their initial deployment of LTE. Went on this so-called upper C block. AT&T FirstNet is substantially deployed immediately above, and so this is the situation overall today. This band exists throughout the U.S. We think it's going to come along in Canada as well. It's not necessarily available in the rest of the world. So those are the current operations. I mentioned there's 20 U.S. utility operators. JEA is the only one that's using this is NB-IoT. The others are using traditional industrial radios from various suppliers. So that's the band that in particular we're recommending. NB-IoT is relevant to Anterix. It's relevant to other bands as well, and it's an option if you wanted to look at it. All right, so I mentioned the 20 utilities. I mentioned the coverage, particularly in this area. And we have gone back to these entities and basically said, are you interested in supporting this standardization? You already have your existing industrial radios, you already have successful operations. Is this something that would be positive? A lot of them have said yes. 6 of them have signed a letter that says to 3GPP, we support this, we'd like to have this band designated for NB-IoT because it doesn't necessarily affect our existing operations. It just gives us an additional option in terms of what we would do. And it's really for different types of applications. So if they choose to split off some for their, I call them wideband industrial radios, low latency, good throughput, high levels of modulation, not necessarily the same range as the NB-IoT, not necessarily the same power consumption. They can do that in a portion of the band and then just use 1 or 2 NB-IoT carriers. So they have supported this. Supported by Qualcomm's, the Quans. Actually, as we meet here, the 3GPP group is meeting virtually at the moment. I don't know where this is. They meet all over the world when they're doing it in person. And they're discussing this proposal. And what my colleague, I don't know if you know Keith from Globally, basically indicated at the intermediate stage. It's making progress. We've got started. The target is to have full 3GP approval of the band by the end of 2022. So, actually, hopefully by the middle of next year. So, at that point, beyond just kind of these initial demonstrations, beyond a limited number of endpoints, they should, at that point, the ecosystem starts to fill up. And really that's part of the promise here is that because you're part of this consumer standard, because you're part of a standard that's supported by T-Mobile and AT&T and Verizon and lots of other different entities, everybody who's making modules and devices that support those networks, now you can have access to that whole ecosystem. And we think it opens up a whole range of possibilities that have not previously been available. So that's a description of sort of where we stand in terms of the 3GPP process. We did this in a sense. You would think that the standard comes first and then the deployments come later, but it turns out that it's actually more successful to get the deployment, at least an initial deployment in place, that you can show to 3GPP, show that it's working, do tests, that kind of thing. And by the way, we had a license to renew, right? You may remember that all of the 700 megahertz licenses were set to expire, if not operational, by June of 2019. So in 2018, we sent out an RFP. We hired the company Globally. It's a startup out of San Francisco. They modified existing equipment that was really destined for networks like Verizon's, to work in this band, and they installed systems in what the FCC calls the Jacksonville license. It actually covers most of North Florida, parts of southern Georgia. In 3 towers, we covered 50% of the pops, right? So two sites in Jacksonville, one in Tallahassee was enough to cover 50% of the pops of a huge geographic area. And put that in place, it's working, it's being used by JDA. They're doing temperature monitoring, they're doing generator monitoring and control, they're doing water pressure monitoring. They expect to use it in their wastewater systems. So they're developing a series of systems. And the system has worked well. It's improved the quality of recording that they're getting from their remote devices. We're starting to look at it as for replacing some of their SCADA. And we see good progress there. All right, so I keep saying 3GPP, 3rd generation partnership project. They never changed the name, even though they went to 4G and now 5G, and I'm sure 6G is coming. But it goes through various releases. And I know that's illegible from the back of the room. I apologize for that. It's also a bit of alphabet soup. But the main point is that NB-IoT was first part of their sort of massive machine capability in release 13. I think approximately 3 years ago was when that became available. It has continued on into the 5G releases. So beginning with release 15, that was the so-called 5G new radio, which is able to accommodate all of these capabilities. We're currently at release 16. The standardization of including our band as an officially designated, we heard earlier, band 71, band 8, band 13, band 14. So in each case, the 3GPP says we designate this particular set of frequencies as an official band, and manufacturers should consider building equipment to the standard and including it. So that's what we're trying to do, is get this one designated as an official band. Maybe band 86, we're not sure exactly how the numbering will come out, but that's the objective. It does not require it to be done at a major release point. So it could be that it's part of release 17, could be that it's part of 17.1, essentially an add-on, could be part of even 16, I suppose, at this point. But this is the release cycle that's continuing, and effectively beginning with release 15, we're looking really at, there's enhancements to what's happening in LTE and 4G, but there's also additions that are happening really only in the 5G radio systems. So what's the workflow that happens at 3GPP? I understand more of this than I used to, but this is a world unto itself, right? They're experts, they have an interesting job, right? And in normal times they get to travel all over the world, highly technical people, negotiations of the standards, testing, opportunities for contribution. So there's a whole process in that green box, which is green on your screen, in the center box there, center area, that is the kind of within 3GPP, how does this consultation go? Who talks to whom? How do we, progress from proposal to comments to testing? That process is going on now. It really began on the left part of your screen with this concept of, hey, we could do this. Other bands are doing NB-IoT. We could add this one, and the objective is to come out with these texts. This happens all the time. There's dozens of proposals that are being circulated through the various committees and subcommittees of 3GPP. It's a standard process, and what I'd say is that our part of this process is going well so far. All right, so why do we do this? I mean, we're actually spending money to hire consultants to push this through. It's basically to create additional demand for the spectrum, of course. It's being paid for by the owners of the spectrum. They want to see these additional uses. It doesn't change anything for those who already are happy with the industrial radio systems. Definitely think those have a whole set of uses that are going to continue. Those are viable ways, good ways to build a field area network or a network that will support a range of applications. But there are advantages that comes from being part of the 3GPP standard. So more devices means lower cost. interoperability is potentially a big issue. We could have a situation where the base station is provided by one or two suppliers in a particular region. The core is provided by a third supplier. The remote devices are supplied by third, fifth, sixth, seventh supplier. Right? All of this can work together, just like my Android cell phone can work with the Verizon network, and so can Andreas's iPhone. Right? That's the same kind of interoperability capability. It's designed to scale big. So, we hear people talking about applications in a more. I've heard Matt Olson talking about a situation where they have multiple connections from the utility to the customer, to every customer. Right? How many sites does that? How many different devices does that take? How do you scale a network of that with distributed generation, with batteries, with the objective of providing much more reliable systems with a declining cost of communications and computing? There's a wide range of what can be done, and this is designed to support that level of scaling. You're also taking advantage of the security systems that are being developed. I mean, if we feel secure enough to bank or trade stocks from our cell phone, part of that is because there's a lot of levels of encryption and security built into that. We'd like to have that same degree of security or greater security potentially in systems being used by the utilities. And then it's an ongoing process. So once you've bought into this, you're no longer single vendor dependent. You're no longer in a situation where you don't have the advantage of ongoing investment and the huge investment that can come from the overall ecosystem. And that can potentially present advantages as well. So I thought I'd try to do, this is a broadband meeting, and I may be, by all means, if people have different perspectives on this, let me know. I hope you can read that. So the group of 5 categories on the top are things that are better if the numbers are higher. And the group of 3 on the bottom are better if the numbers are lower. So we want high power efficiency. NB-IoT is more power efficient. We want high data rates for a lot of applications. I can't do it on NB-IoT. I need a broadband solution. And likewise, if I need low latency, NB-IoT is not, we're talking about 1 or 2 seconds of latency. If that's not going to cut it, if you need milliseconds of latency, you need a broadband solution. And similarly, you can go through this, the range, the environmental protection, the scalability, I think are advantageous in the NB-IoT world because that's exactly what the system was designed for. And so I would encourage you, as you look at applications and think about what you need to do you have enough applications to support this? Maybe you don't. I think a lot of utilities, when they look at this, will say, well, wait a minute, a significant number of my applications could be done on an NB-IoT network. Is this a better way to do it? So that's my belief. I'd be very interested to work with any utility that'd like to go through a list of applications and see what are supported and what are not. Okay. Talked about 3GPP. At the moment, this organization is driven by Nokia, AT&T, Qualcomm, Vodafone, it's a global organization, Huawei. It's driven by a bunch of parties that are not utilities. And mostly that's good, right? They're very invested in the wireless business. They're putting lots of R&D into this. But there is some risk in that, right? This industry is becoming more interested in private LTE, private 4G. I say private 5G is coming. And so should there be, direct representation from this group that kind of, checks and says, hey, are you developing at least aspects of these standards for our needs? So I've put this to UTC, which would be a logical entity to represent the organization. There are expenses to join this. It's gotten to be a lot less in terms of, because the travel has disappeared. That hopefully will come back before too long. But it also takes expertise and it takes time, and you know, you're dealing with some of the most qualified engineers in wireless in the world, I would think. So you know, it takes some pretty smart folks to do this as well. So at least a question that I want this organization. We heard John Hughes at the national show say that Ameren plans to spend about $500 million on their LTE network. So if they're spending $500 million at just that one utility, you know, what is it worth to the industry to make sure that the standards are looking out for utilities? You're still going to be a small piece of the global $1 trillion+ wireless business, but you know, maybe you want to have a voice in that arena. In the meantime, we have hired Paloli, as I said, to push through this standard for 700 on NB-IoT, and I know Anterix has things working at 3GPP, and I'm sure Nokia has things working at 3GPP. So there are voices, but you know, they're filtered, right? More coming through the vendors rather than directly from the utilities. Okay. Any questions just on NB-IoT before I go on? Because I'm fixing to change direction here. Yes, sir. Okay, hold on a second. We're going to get you a mic.
I want to make sure the folks virtually can hear.
Okay. Do I need to?
In-band and not-band.
You know, I am not certain of that answer. I know that the standalone can offer longer range because there isn't the compromise of the power levels between the in-band. It could be that the guard band is just as good as the standalone.
That's what I was thinking. The guard band has so much noise.
There would be noise. That's true. You may be cleaner in a standalone. That is what we're looking at initially. Our neighbors, of course, are AT&T and Verizon. So, you know, unless one of them suddenly gets interested in this band, and you know, they have not shown that other than interference management stuff, they are doing that. I don't think we've had any indication that they're interested in doing the guard band solution or the in-band solution.
But it's still a lot of network. There is still using the CAT-A, not doing the NB-IoT.
Doing CAT-M.
Yeah.
Yeah, so CAT-M is another, I mentioned there's two flavors of this massive machine-to-machine communications. So NB-IoT requires 200 kilohertz, and we have 1,000 kilohertz paired, right? So it fits. CAT-M requires 1.4 megahertz. We at Beach Point and Access Spectrum, we have 1,000 1 kilohertz or 1 megahertz. We are 400 kilohertz short of what is the minimum required for CAT-M. So that's why I'm not talking about CAT-M. but if you have 1.4 megahertz or more, that could be a better answer. It's kind of a compromise, right? It has some of the long range and ability to scale, but it doesn't have the same fast throughput that is available at the full broadband 4G. Okay. Any other NB-IoT questions for the moment? We do have another. Yeah, Bruce.
So do you have a feel for once you get your 3GPP designation or band designation, how long before the chipset vendors get that into the chipsets, or have you started looking or talking to the chipset vendors about that?
So we have two chipset vendors that have produced pre-standards versions of this. One is Sequans out of France, the other is Qualcomm, out of San Diego, right? And in each case, they took an existing, I think it was a Verizon chip, but their existing chip, and just did a software change. And so, those are available today. They're pre-standard. Presumably, the software may need to be tweaked. They've been put into modules. They've gone through FCC certification. So, hopefully, at least those two, minor change, goes through very quickly. And they support lots of devices, so lots of modules. Sierra Wireless, Telit. We also have Telit, by the way, and Quectel in terms of module makers already. So we think some will be out there right away. But we are very interested in facilitating others. If anybody has an application that they want to do, you know, we have this network that's operating in Jacksonville. Potentially we could load it up there. We're hoping for another party to do kind of a demonstration network with this that is designed for testing and prototypes and things like that. But you know, Anterix was wise, right? They set up this kind of ecosystem type orientation. You know, really, I envision the same kind of model, and this is very much one of cooperation. But you know, part of it will just happen. You know, there's pull, right, coming from the utilities. There's also push. Once we get that standard, then all the chip makers will say, okay, well, we got to do this, right? If we want to. And they see significant opportunity. You know, this is private networking is becoming very, very important. So I think it's you know, quarters to get significant number of devices out, and frankly it's years to get the kind of full proliferation that we would expect. It's going to take time. Okay, let me switch topics now. And put on the broadband side of this as well. So our view is for some applications, utilities should have broadband, and you know, it's going to take time for them to build in the budgets and so forth. Our view is a way to go after this is looking at two separate frequencies. And the 700 megahertz has excellent propagation. It will support NB-IoT. You know, there's existing vendors. You could do this now. You don't have all of the full range of suppliers we'd like to have yet, but you know, I think others are getting on board, and so you could build, you know, with 25-mile radii. It doesn't take very many sites to cover a pretty significant amount of territory. And so if you look in this side, the kind of shadow for the narrowband has a wide coverage area, and the concept is start there, get full coverage. You can support a lot of applications that way. Where you need broadband, we can help. We can certainly find I mean, first of all, CBRS on GAA is available everywhere, right? You may be contending for it, but it's substantially available. We've just, we actually bought some licenses, some PAL licenses. The auction, we've just done the first lease. Andreas here finished that recently. For the first lease of a PAL license, we think, in the country. So we're pleased with that. We intend to be the leading broker and market maker for CBRS PALs, and that will be not just leases, but also sales, not just whole PALs, but also partial PALs. So they can be a fraction of a county. They can potentially even be, you know, half of the spectral capacity, 5 megahertz. So these are going to be available. We don't really have a good idea what the commercial terms are going to be. The average price per megahertz pop for CBRS in the auction was 22 cents, I think. Remember? A little higher. I would say, if we closer to 30, Andrea says. Some of them went way below that. The ones we bought were generally lower. Obviously, the major cities were higher. The more rural areas were lower. But CBRS is going to be available either GAA or purchased or leased PALs. And please come to us, and we'd like to help you find those, you know, as in our goal of sort of building up this market. We're building a software system. We call it CBRS Direct. It's going to allow, you know, look on the web, say what you want, point and click, draw a map of the area of the county that you want to buy, ask for it, and hopefully a seller will show up to sell or lease it to you. So that's working. There are other frequencies. We've done a lot of work in 2.5, and we think there are other frequencies that are going to come on the market for broadband as well. So our recommendation is start with 700, and in this duet environment, you could also soon have access to other frequencies. So this is kind of a different way of looking at it. You mentioned Cat M1, so this is the higher capacity within the machine communication space. NB-IoT, you see there, whole range of different types of applications that they can support. And we see that, you know, by tapping into this really global view, wireless industry view of how these machine-to-machine communications can work. You can take advantage of these standards in a whole range from, that's being adopted by other industries in parallel with the utility industry. So this is, I think, mostly a repeat of what I've said. The concept is that because you get such broad coverage, because the purchase of 700 megahertz licenses was only 2 megahertz in total, as opposed to 6 or 10 that you might buy for a broadband system, and because the unit rate is a bit lower, you're going to be more cost effective on the spectrum. You're going to be more cost effective on the operations because there are fewer sites. This is a way to get going. And you can still use, all of the advantages of the 3GPP standards. You can still use a given, in this case, we showed, a standalone NB-IoT transmitter in the middle. In fact, you could certainly use the same radio systems or much of this common hardware, tower, controller, eNode B. You need probably different antennas and amplifiers, but to handle the broadband. So there should be some efficiency in there. And this is a model that's well proven, right? If you go to any of the major carriers anywhere in the world, they're using low frequencies to cover broad areas, and where they have capacity requirements, they use additional higher frequencies. Now, theirs is typically today predominantly broadband, both at the low frequency and the mid-band. We're suggesting starting with NB-IoT in the low frequency and moving to your capacity broadband system would be in the mid-band. But this is one that's being used by all the carriers, so it's proven technology in 4G, starting to be used in 5G, and you're following a model that has been shown to work in what's obviously a highly lots of R&D going into that business, and you can take advantage of that. So I mentioned, an alternative here. We're saying CBRS is the most generally available, but please come and talk to us. And we expect that in many cases we'll be able to talk about additional frequencies in addition to CBRS that we could recommend. CBRS happens to be particularly nice because it was auctioned at the county level, so that typically fits pretty well with the way the utilities operate, and you could assemble a group of counties if that's what you wanted to do, or subsets of counties if that's where you have capacity requirements. All right, we're up to the Q&A. We had a couple of good questions or comments already. Do we have more?